Ladies and gentlemen, welcome to another video. Today we're diving into a little different topic, some Calc AB. We're going to do some separable differential equation, I think, diff-eq, whatever it's called. I don't know. Still have a bunk bed and a ring light. I need a haircut, but first we got to do some math. Let's go.
All right. Before we get started, I just want to kind of lay an outline and just go over some steps because each problem we will do will follow these same steps and routine in order to get the answer. So first thing we have to do is get all the x's and y's onto their own side. So by the end of this step, it will be all the x's equal all the y's. So we couldn't have an equation like 2x times y equals y squared. You can't have x's and y's on one side, if that makes sense. So after that, we have to do the integral of both sides. So integral of all the y values, integral of all the x values. So pretty straightforward there. And then after we do that, we have to solve for y. And so that means pretty much like we can't have y squared equals blah, blah, blah. We just have to have just y equals. And then step 4, this is only for if you're given x and y coordinates. Like the first two problems we do, we are not given coordinates, so we just end at step 3. But if you're given x and y coordinates, you have to solve for c. And so you just plug those coordinates in and you're good. And then after that, you just plug in c to get your final equation. And that's pretty much it. It sounds confusing now, but I promise you it will make sense once we start doing some equations.
All right, like I said, working on a separable diff-eq today. I'm going to break it down into two parts, really. First, we're just going to get, a general idea of how to separate them, what to do, when to do the integral, stuff like that. Then after that, we're going to solve out for them and actually get the equation. You'll see. But yeah, so I'm going to leave a link to all the problems and the answers. I'm only going to do 6 of them today, but if you want to do all of them, be my guest. Like I've said before, Calc AB is it's all about just doing tons of practice problems, getting that extra work in, because the more you do it, the easier it becomes. I promise you, I had to, grind out my math labs, and I hated every second of it, but it actually helped out in the end. I hate to say it, but it did. All right, so first things first, when we're doing this, we just have to get all the y's to one side and all of the x's to one side. So no matter if there's a d in front of it or it's just, an exponent, we just have to get all the y's to one side and all the x's. So how do we do that? We just multiply a dx over, and we multiply a y squared over. And the denominators will disappear, and we'll just get y squared times dy equals x cubed times dx. And then once we have them separated, all we have to do is just do the integral of both sides. So I just do the integral. Those are two bad integral symbols. It's okay. So integral of y squared. And also when you do the integrals, these just cancel out. Like they're not really important. They're just there for notational reasons. And from there, we just do the integral of y squared. Should be memorized. 1/3 y cubed. Then equals, same premise here, 1/4 x to the 4th. And you can check those by doing the derivative of both. And if you do the derivative of both, you'll just get y squared and x to the 3rd. Promise you. And then also, when we do the integral, we have to add, our arbitrary constant. I always add it to the x side, but you can add it to the y side too. It doesn't really make it a difference, but I normally put it on the x. So from there, all we have to do now is solve for y, because we're making an equation out of this basically. So from that, just regular algebra, we just go times 3, y cubed equals 3/4 x to the 4th plus c. Now I know you don't have to add the times 3 over, because like I said before, it's not a variable, it's just a constant. You don't have to actually times it by 3, because especially in the later problems like 5 through 12, we will solve from the constant because we will be given an actual value, an actual x and y value. But for right now, we don't have to solve for c. We just add it there. No added numbers, anything. It's just plus c. And then there, we just take the cubed root of both sides. I'm running out of space. And then we just get y equals the cubed root of 3/4 x to the 4th plus c. And that is your answer. So super simple stuff. I mean, granted, that is probably the easiest problem you will get when it comes to diff-eq, but you know, that's just the basic premise of it. Get the y's and x to one side, do the integral of both sides, have the plus c, and then you just solve for y. Super simple. You know, it just takes a little bit of practice. All right, on to number 2. Almost the exact same problem as number 1, just different values. This is just going to be kind of like the last warm-up one before we get into, you know, the harder ones. But, you know, same thing. Even though there's not an x over here, we still have to get the dx over because, you know, we need the y's isolated on one side. So we can just multiply dx, multiply secant squared y. And, I mean, I guess you could divide the dy over to this side and that would separate them, but, like, if I'm going to be honest, that's not smart. That's just a dumb move. It makes everything harder for you. Like, I don't know why you would do that. But, yeah, just never do that. So we just multiply it over and it becomes secant squared y times dy equals dx. And then from there, once we separate both sides, we should do the integral. Let's get a saucy integral sign. Nope, never mind. Those are mid. All right, so from there, we just do the integral. Now, integral of dx, that's just going to be x because dx is basically saying the derivative of x, and integral is getting rid of the derivative. So we just have x here. And when I do the integral of the x side, I always add the c. I never do it on the y side. I always find it's easier. So from the integral of dx just gives us x plus c. And then from there, we can do, because it's also like saying the integral of 1 times dx, and the derivative of x is just 1. So the integral of 1 is just x, if that makes sense. But if you ever just see integral of dx, just put x. Or like integral of 5 dx, put 5x, you know. Sorry if that's confusing, but just remember that. All right, and so then we just have integral of secant squared y. That's one of the memorized integrals. It's just going to be tangent y, if the dy is gone. I keep doing that. I erase it with my hand. And so now we have our equation, and we just have to solve for y. I wouldn't say this is tricky. It's just something you don't really see too often with the tan here. And we have to get rid of the tan. In order to just get y, we do tan inverse of both sides. And so then we just get y equals the tan inverse of x plus c. And that is your answer right there. So yeah, super simple. We're going to get into some harder stuff where we actually solve for the c. But yeah, just, you know, little warm-up problems. And also, just a little side note, I write out all the answers on the paper, and all of the answers are in the link. So if you just want to skip ahead and, you know, because you already know how to do it, totally fine. I just write them out there just for reference. All right. Number 5, dy dx of 2x y squared. So simple, pretty, you know, straightforward problem. But you look over here, there's a comma, y2 equals the cubed root of 13. And basically what that's saying is that gives us a point. So once we get our y equals equation, we're going to plug those 2 points in order to get our c value. So I'll explain that a little more later, but I'm just going to write that up here. It just gives us a coordinate 2 cubed root 13. So we know 2 is our x value because it's like saying y of x equals, you know, blank, a constant. So it's the y, it's, this is our input value and that's our output. Output goes with y, input goes with x. So we're inputting an x value of 2 to get a y value of the cube root of 13. I'm really bad at explaining if you haven't noticed already, but that's the best I can do. So from there, I mean, honestly, it's a lot like number 1 again. Just, we just, isolate the y's and the x's on one side. So we multiply the y squared over, we multiply the dx over, we get y squared dy equals 2x dx. Integral. That was decent. Now we get another memorized one. Just equals, what am I doing? Oop, that's not right. We just get x squared plus c. And that's pretty much it. That is just your two integrals right there. Yeah, a lot of the time with the diff-eq problems, the integrals are actually not too hard. A lot of times you'll either have problems like this, or sometimes you'll have like a 1 over y squared, and then you have to get into like inverses, or sometimes the natural log of something. That doesn't happen as often though, but yeah, the integrals here are, normally pretty simple. So as I'm ranting, we got to solve for y, multiply both sides by 3. And remember, that's just a constant, it's not a variable, so we don't actually have to add that times 3 over, just to the x squared. Then we can do the cube root, and we get y equals the cube root of 3x squared plus c. And so now this is where we, itchy nose. This is where we solve for the c value. So like I said before, it gives us an x value, it gives us a y value. So now we have to plug those into the equation to solve for c. So I'm just going to take it up over here. So now we can plug in the cube root of 13 for y equals the cubed root of 3 times 2 squared plus c. And then from there, we just solve for c. So in this case, we can cube both sides to get rid of that root. And we just get 13 equals 3 times 2 square rooted plus c. And now we just get 13 equals 12 plus c. Subtract the 12 over, and we get c equals 1. So we have our c value, we have in our equation, and it's super simple. Just to get your final answer, we just add the c value in. So our final answer is going to be y equals the cube root of 3x squared plus 1. And yeah, that's your answer. All right, number 8. So we have an equation here. First thing that I'm going to do is I'm going to write out the coordinate it gives us, or the x and y value. I'll write that over here. So our input is going to be -1, and or our x value is going to be -1. And when we put that into the equation, we get out a y value of, whoa, that's not very nice, okay, of the cube root of e cubed plus 3e squared all over e. That is one of the weirdest values you will probably see. Hopefully it gives us a nice c value, but I guess we'll have to see. So first things first, as always, get the y's on one side, get the x's on the other side. Same thing we've been doing. We're just going to multiply the dx over, multiply the y squared over. I mean, I'm sure you know that by now. We've done it a bunch. But just doing it again. And we get y squared dy equals e to the x dx. And obviously from there, we do the integral of both sides. And we've already done the integral of y squared before. I think it was the last problem. It was. And we know that is just going to be 1/3 y cubed equals, and just remember, whenever you're doing the derivative or integral of e to the x, just e to the x, it's always going to be e to the x. And then we'll just add a plus c there. And there we go. That's the integral of both equations. And now we know what we have to do after that. We have to solve for y. So we multiply 3 over. Once again, this is just a constant. It's not a variable. So we do not multiply the c by 3, just the e to the x. We get y cubed equals 3 e to the x. And then we can do the cube root of both sides. And we get y equals the cubed root of 3 e to the x. Oops, forgot the plus c. And that is our equation. Now we can take it up here to our x and y value, plug those in, and now we can solve for c. So we have, not y equals, we have this really weird number equals e, then equals cube root of 3e to the negative 1 plus c. All right, so first things I'm going to do, I'm going to, kind of simplify the things I can. And right away, I'm just going to take the cube of both sides so we can get rid of those radicals. And then we get e cubed plus 3e squared over e cubed, because this was e, and then we took, because when you raise a fraction to a power, you have to raise both the numerator and the denominator to the power. So since this wasn't under the cube root, we have to make it e to the cube. And this other side just going to be 3 over e plus c. I just did a little bit of simplifying there. E to the negative 1 actually just equals 1 over e, so I just simplified that. And this looks like a mess, and it kind of is, but the first thing I'm going to do is I'm going to simplify this whole equation to make it a little bit better, and so we can, hopefully solve it. So first thing I'm going to look for is something we can, simplify our factor out of the equation. And right away, I see we can factor out e squared. So I'm going to do e squared times e plus 3. It's the same thing as e cubed plus 3 times e squared. It's going to be over e cubed. I can just cancel that out. Cancel that out, not completely, but then I can get a new equation of e plus 3 over e, because we took 2 out from there and then 2 out from the 3 to just get us e. Now we have 3e. Actually, wait, I'm not going to do that. I'm going to do some more simplifying first. And so when you have a common denominator, you can actually split up the e and the plus 3 to get e over e plus 3 over e. And now we can set that equal to 3e plus c. And that just gets us minus 3e. And we have c equals e over e, which just equals 1. So it really did work out. That was kind of confusing. I would suggest, going back and, looking at how I did that or slowing the video down, because that was a whole lot. But in the end, we got c equals 1. And just like from there, we can just substitute our e value in, plus 1. And that is our answer. One of the harder ones, especially solving for that c value. I do think, solving for that c value is the hardest step in these separable differential equation problems. But, just the more practice you do, the easier they get. Alrighty, number 9 now. I already wrote out a coordinate because I feel like It's, you know, all of you understand how I get the coordinate, how, you know, and how you're supposed to and stuff like that. So I didn't really bother with, you know, writing it out and explaining it. All right, so like always, first step, get the x's and y's to one side. So we have sine y dui equals a negative dx. Then, of course, sorry, I'm going to start going kind of faster because we've had some experience now. We're going to take the integral of both sides. So the integral of sine y is going to be a negative cosine y. And really, with these, with like the trigonometric problems, you just have to think to yourself, what derivative gives me sine? And we know cosine, the derivative of cosine gets negative sine, so it has to be the derivative of negative cosine to get a positive sine. And that's just basically my thought process through it. Pretty simple, but it, you know, it gets easier with more experience. And then we know the integral of dx is just x, but there's a negative, so it has to be negative x, and we can do plus c. And right away we have a negative on both sides, so I'm just going to simplify that out to just get cosine y equals x plus c, because really you can just divide both sides or multiply both sides by a negative 1, and you know, we'll just get, and we just get cosine y equals x plus c. It's the same problem, it just, I like it when there's no negatives. I think it's easier, looks better. And so now we have to isolate the y over. I wouldn't say this is tricky, you just don't see it as often. In order to get the cosine on the other side, we have to do the inverse of cosine. So then we get y equals cosine inverse of x plus c. So now we can go up over here to our coordinates. We can plug them in, and we get, excuse me, we get pi over 2 equals cosine inverse of 3 plus c. And now this is kind of funny. Normally I solve for y first, just because it makes it easier. We don't have to do it later. So once we get the c value, we can plug it in. But in this instant, it would have actually helped us if we didn't solve for y, because now I actually have to do the cosine of both sides in order to solve for this. So it was kind of pointless doing it, but you know, I don't know, maybe it made the problem a little shorter. Probably not. We'll see. And so yeah, from there, we just, you know, solve normally. So we have to do the cosine of pi over 2. So on your, what is that called? Unit circle, that's going to be like the very top of it. And so the cosine is going to be the x value of the unit circle, pi over 2, and that's just going to be 0, right? Yeah, because sine of pi over 2 is 1, so that has to be 0, which makes things a lot easier. So c just equals negative 3, and we can just go back, plug that in, and we get y equals cosine negative 1x minus 3. And that is your answer. So that one's a little more simple. I mean, this one kind of just introduces, you know, the sines, cosines, SOHCAHTOA into the diff-eq problems. But yeah, super manageable, super easy. All right, last problem here, number 12. Already wrote the problem and the coordinates, I'm pretty sure. You know how I got that by now. So, same thing as always. You already know, gotta separate both sides. Get the y's on one side, get the x's on the other. Y squared dy, 1 plus x squared dx. And once again, I'm sure you know by now, gotta do the integral of both sides. You know, after doing these problems, I'm getting really good at writing integrals. Like just the symbol itself. And I think this is the third time we've had to do the integral of y squared. So I'm sure we know it. just memorized one, just a memorized integral. 1/3 y cubed equals, now the integral of 1 is going to be x, and then the integral of x squared is going to be 1/3 x cubed plus c. I don't know why I said it like that. And then solve for y, multiply by 3. Remember, don't never put 3 times c. It's always just c. Then we have y cubed equals 3x plus x cubed plus c. Now we can just do the cube root. This is kind of similar like the ones we did in the beginning. It's just that you're adding that extra x instead of just having x cubed. Like, trust me, the problem will work out just the same. Won't be too difficult. Hopefully not, at least. Wow, that stretch of 3x to plus c is, that's some of my best handwriting right there. I do not shine in the handwriting, industry, so I'm pretty proud of that. Anyways, moving on. Bring this equation up here, and now we can plug in our y value and our x values. And we can get 3 times -1 plus 3 times -1 cubed plus c. And I'm just going to simplify all that out, all of the multiplication and stuff like that, just to make it easier for me. And that's going to be -3 minus 3, because the cube root of -1 is just -1 times -1, which is 1, and then times another -1, which is -1. I'm sure you knew that, but just trying to explain it. So -3, and then plus c, and we can simplify that again. Get cube root 4 equals -6 plus c. So super simple stuff. Now we just got to do cube both sides, and we can get -4 equals -6 plus c. Add the 6 over, and we get c equals 2. Bring the c over. Y equals the cube root of 3x plus x cubed plus 2. Sorry, I kind of speed ran that problem. I felt like it was pretty easy, though. I'm sure all of you could have done it by yourself. Normally the later problems are supposed to be the harder ones, but I guess not. So yeah, that is it for me. I really hope this, helped with the diff-eqs. I remember struggling with them when I first had to do them in class, and just searching up example problems and doing them really helped me out. So, I suggest you do a couple more. If you don't, feel comfortable with doing them by yourself, just the more you do them, the more confident you'll be, the easier they will get. And yeah, so that's it. Thank you for watching, and I will see you all later.